We normally start this problem if we wanted to find the area of a circle. What's the formula for the area of a circle? Area equals pi r squared. But what's the issue with setting it up like that? We don't know the radius. So we need to use the area of a sector formula. The area of the red sector, area of the red, is equal to what? Cody? Yeah, buddy. 135 over 360. Is that it?
Equals or times
What?
pi 48 squared.
No. So you're on the right track. It is going to be pi r squared, right? But in this case, I already said this. We don't know what value. That's super important. We don't know the radius. Do you guys agree that pi r squared is the same as what? Pi r squared is the same as what? The area of the circle, correct? So now if I solve this equation for capital A, will I not have the area of the circle? Try it. You know the area of the red section, so plug that in on the left. Multiply by the reciprocal and try to get the area of the full circle. This red section is only a piece of the whole circle. It's 135 degrees out of 360. So that's why we set up a ratio. We're saying if we take 135 over 360 and multiply it by the area of the whole circle, we'll get the area of the red section of the circle.
How would we know what the area of the circle is?
We don't. That's what we're trying to find. But what we do know is we know the area of the red section. It told us the area of the red section is how much? 48. So we're plugging in 48 to the left-hand side equals 135 over 360 times A. Does anyone remember how to solve an equation like this? Nick? What is the reciprocal? 360 over 135. Multiply by 360 over 135. Do it in your calculators now. The 130s cancel, the 360s cancel. So we just have area on the left, the right-hand side equals. Christian, what'd you get? No? Sophia, what'd you get? 128 is correct. But we're missing units. Feet squared. Why squared? It's area, baby. Dylan, was that a hand to answer or a hand for question? Okay. Hannah? Which part?
The area above, there's another equation that says area equals pi r squared.
Yep.
But that's, is that what you did?
No, it's not. So area equals pi r squared is what you should use if you have what value, Hannah?
The radius?
The radius. Did we have the radius here? No. So we have to use the area of this sector, which is the area of the red piece is the ratio of the arc over 360 times the area of the whole circle. So that's what I used here. I knew the arc was 135 degrees because the central angle was 135, and the area of the red section was 48. What's a polygon? Not 6 sides. Not 4 sides. It's a shape. But this specific shape has sides. Do you guys agree? Polygons have sides. Did circles have sides? Guys, a polygon is also not a 5-sided figure. What is a 5-sided figure? A pentagon. Polygons is like the blanket umbrella for all of them, okay? What is a hexagon? 6-sided figure. What is a septagon? 7. What about an octagon? 8. How many sides does a 4-sided figure, or what do we call a 4-sided figure? Quadrilateral. Okay, you guys got it. So you remember that chart that I gave you before? If you need to refresh yourself on that chart, go ahead and go back because that's very important here. The first 2 polygons we're going to talk about are a kite and a rhombus. Now, the cool part is they share the same formula for the area, okay? The area of a kite and a rhombus from now on, we will use as 1/2 D1 times D2. Now I want you to look at these two figures. The figure on your left is a rhombus, and the figure on your right is a kite. Someone explain to me what the measurement of D1 and D2 are. What do they represent in these figures? The length of what? What? The base and the height is incorrect. What did you say, Sophia? You didn't say anything? Who said something with a D over here? Not diameter. The diagonals. Guys, the diagonals of your kite are D1 and D2. Now, the formula is such that it does not matter which one you make D1 and which one you make D2, but they are the diagonals. Now, what? They are, but Hannah, they're gonna list them outside the figure, the length of them, because if they listed it in here, it would get confusing. Because if they put an 8 here, right, you wouldn't know whether that 8 was the half the distance or the whole thing. Okay? Second thing, guys, the diagonals of a rhombus and a kite, they both have this property. They form a 90-degree angle where they intersect. So make sure you fill in that 90 for both of them. What questions do we have on this first slide? All of them, yeah, they would all be 90, all those angles. Okay, so now this doesn't necessarily matter, okay? But we are going to prove it because I want to show you where this formula comes from. You're not going to have to do this on an exam. You can just straight up use the formula, okay? So the next, I do want to show you where this formula is coming from, okay? So, no, can you close it? Thank you. It's too bright and then people can't see the screen. Okay, so guys, diameter, no, not diameter. Hayden, when you said diameter, now I have diameter stuck in my head, okay? It's a diagonal. So diagonal 1 and diagonal 2. Guys, the diagonals also bisect each other. So they're cutting each other in half. So what we're going to do is we're going to represent exactly this piece and this piece, where we know that this angle is 90 degrees. Okay? What shape do you see with those two sides and this side over here? What kind of triangle? A right triangle. Very good. Okay? So, what is the length of this piece? We'll call it X for right now. What is the length of X in terms of either D1 or D2? It's half of what? D2. So let's erase the X and let's put half of D2. And then let's do the same thing for that top side, the top side on top. How could we represent that side on top? Half of D1. Very good. Now, we already talked about this in our homework. Let's find the area of this triangle right here. Because you guys agree that triangle repeats itself how many times in this figure? 4. So if we can find the area of that triangle, we multiply it by 4, we should get the area of this rhombus. Let's check it out. So let's find the area of this triangle. So we're going to write area of triangle, I'll abbreviate with TRI, equals, what's the area for a generic triangle, guys? 1/2 base times height, okay? Now, this one's kind of like inverted a little bit, right? But what could we make the base of our right triangle that we drew? What could we make the base of our triangle? Which side could be the base? That you want the hypotenuse to be the base? Okay, but Hannah, do we know any information about the hypotenuse? Other than it's the same length as the other ones, right? And then that would also force us to find a new altitude, right, for the height. What could we use as the base? 1/2 D1. Let's make that our base, okay? So if we make 1/2 D1 our base, let's plug that in. It's 1/2 D1. Remember, we still have a 1/2 out in front. And what can we use for the height then if we make 1/2 D1 our base? 1/2 D2 could be our height. Very good. So let's make this 1/2 D2. No, you were right. You were right. So what can I do here? What can I do here? Can I multiply the 1/2? Sure, I can. What's 1/2 times 1/2? A fourth, and then times 1/2 again? It's 1/8, right? And then we still have D1 and D2, okay? So the area of one of these triangles is 1/8 D1 times D2. Now, let's repeat this. How many of these triangles do I have in my figure? 1, 2, 3, 4. So what do I need to do with this area? If I multiply it by 4, that will give me the area of the rhombus is 4 times 1/8 times D1 times D2. What's going to happen here? 4 times 1/8 becomes 1/2. Is that not the area formula for a rhombus? Boom roasted, we just proved it, okay? Now, you don't have to have this memorized. You don't need to actually know this, but I just want to show you where this formula is coming from, okay? Didn't just poof out of thin air. They separated the figures into right triangles, and they showed that the area of each of the triangles is 1/8 D1, D2, and then they found that, okay, if there's 4 of them, then there has to be 1/2 D1, D2 for a rhombus's area formula. Go ahead, Zach. Talk to me. What questions do we have about this? All right, and then 2 examples is more of what you would see on an exam. So let's move on. Let's go ahead and apply let's apply this formula to 2 examples. So the area of the rhombus, we're going to use the formula, which is 1/2, area equals 1/2 D1, D2. Does it matter which one I make D1 and D2? No. Okay, which one would you like D1 to be? 8? All right, let's make D1 8. And then D2 has to be 6. Plug them in. So area equals 1/2 times 8 times 6. You don't need a calculator for this. What's 8 times 6?
48.
What's 48 divided by 2? 24. Now, be very careful about your units here, peeps. Meters? Squared. Why squared, people? It's an area. It is that easy. No? Bryson? What does the D mean? Diagonal. Okay, so diagonal 1 and diagonal 2. Yes? Why didn't I half it?
Yeah.
I did.
You didn't have 8 and 6.
Oh, remember, you only distribute the 1/2 to one of them, right? You would only distribute if there was a plus sign between the 8 and the 6, okay? So you only half the 8, which becomes 4. Then 4 times 6 gives you 24. Okay? Good question. Yeah, Sophia.
Does it matter which side you put in D1 and D2?
D1 and D2 does not matter, okay? You could have done 1/2 times 6 times 8. You would have gotten 3 times 8, which is also 24. Okay? Yeah, Cody?
Now the 24 meters squared is the whole entire.
That's the area of this entire figure. Yep. Cool beans. Any other questions? These are good questions. Jayo, yes, you can go. Okay. No, letter B. It's a kite now. Do you guys agree? Looks a little bit different than a rhombus. But it's the same formula. Very good, Dylan. So we're going to write A equals 1/2 D1 D2. What do you want D1 to be? 7? Okay. D1 is 7. What would D2 then be? The 10. Plug them in. So it's going to be 1/2 times 7 times 10. 35. Because 7 times 10 is 70. And then divide that by 2, and you get 35. Oh, you'll also have a calculator, guys, so don't feel like you have to do this in your head. Hannah? Very good. Thank you for remembering the units. It's going to be centimeters squared. Okay? Talk to me. What questions do we have so far? So pretty easy formula for kites and rhombuses. Do you guys agree? Cool. How much harder does it get? Just a bit. Just a bit. Do you remember sine, cosine, and tangent? Oh. Yeah, they come back. All right. So, guys, in a regular polygon, what is a regular polygon, first of all? You don't remember? It's okay if you forgot. Yes. What's all equal?
All the sides are equal.
Yeah, buddy. All sides. That's so good, Juan. All sides and angles are, and I'm going to put the congruent symbol, that they're congruent, okay? All sides and all angles are congruent for a regular polygon, okay? So there are some things that we need to go over. We've pretty much already talked about a lot of these, okay? The center, okay, the center of a polygon is going to be the center of the circle that surrounds your polygon. So check it out. Down below, they have what kind of polygon in the middle? What kind of polygon is that? Has 6 sides. What's the 6th one? A what? Hexagon. Very good, okay? So in the hexagon, the center of the hexagon is the center of the circle. What's the center of the circle? Point P. Very good, okay? So point P is also the center of our polygon. The radius of your polygon is the radius of the circumscribed circle. That means go from the center to a vertex. So this length, PM, and this length, PN, are both radii, okay? Your central angle is an angle formed by 2 radii that are drawn to consecutive vertices. What does consecutive mean? Like one after the other, right next to each other, right? So do you see how M and N are next to each other on the polygon? They create a central angle when you draw their radii back to the center. So our central angle here, who can give me the 3 letters for the central angle in this figure? MPN, is that what you said? Yeah. That is correct. You could also reverse the order and put it as NPM, okay? Do not involve Q. Q is a different thing. Q is not part of the central angle, okay? The apothem, this is the new one, star this one. We have not seen an apothem before. An apothem is the perpendicular distance from the center of the polygon to a side. What does perpendicular mean again? Forms a 90-degree angle, okay? So as you notice, which is the only segments that forms a 90-degree angle with a side? PQ. PQ, and list this, is our apothem. Okay? We have not seen that apothem before. Yes?
So is the apothem like the radius?
The apothem is not like the radius. Why isn't it a radius, guys?
Okay, wait. I know
It doesn't touch the edge of the circle. Do you see how it's missing a piece right here, Christian?
Yeah, but I mean, like, is it like in the way that like it goes from the center?
Yeah, it goes from the center to the edge of the polygon, but it cuts the side in half, okay? So guys, some cool things that happen, and you need to write this down. The apothem is going to bisect the central angle. That means 2 angles here are going to be congruent. They are MPQ, and guess which other angle? NPQ. Very good. Those 2 angles will always be congruent to one another. And then the apothem also bisects the side of the polygon. So MQ is the same length as what? NQ. Okay? Make sure you fill those in there. What? Yeah, I can. Is that good?
Yeah.
Anything for you, Christian. You're welcome. Okay, bring it back, bring it back, bring it back, bring it back. So we now have to talk about something called central angles. The central angle of any regular polygon is 360 divided by n, where n is what? The number of sides. So if I'm dealing with an octagon, what is my n value? 8. So my central angle, how do I find the measure of a central angle? 360 divided by 8, which in our calculators, if we plug that in, is 45 degrees. Have we already done this before? I don't remember doing it before. We have done this before? I think what we did before was we divided an arc, right? Because it was a regular polygon, and they were all arcs of the circle, all chords, excuse me. And we divided it by 360, or 360 divided by the number of sides. That was a question we've seen before. Okay. Let me know when you're ready, Amanda. Yes. No. In the diagram, this is a square. Are squares regular polygons? How do you know? All the sides are the same length. Go ahead and throw those congruence marks in there on your figure all around the square. Okay, let's take it step by step. Let's identify the center of the polygon. Where is the center of the polygon? Point P. Very good. Let's list it out here. Center is point P. Where's the radius? What? What? PY is one of them. What's the other one? And PX. Guys, let's be very careful about notation. What needs to go above the PY and the PX? A line like this. Thank you, Carson. A segment mark, which means it stops on both ends. No arrowheads. Dylan? Okay, then we're going to go ahead and list the apothem. QP, very good, or PQ. Also a segment, not a ray, not a line, not a point. PQ. And the last thing is the central angle. What's the central angle? German? XPY. Do we agree with German? Is XPQ a central angle? No, because it used the apothem. Remember, central angles are formed by two what? Two what? Not apothems. Two radii. Very good, Cody. Okay? They're formed by two radii. Yes, go ahead, Cody. Yes, but also you have to use two radii. Okay? Q is part of the apothem. Do you see the difference? Cool beans. All right. Next, we have to find the actual measure of each one. So we need to find the measure of XPY. So let's list it out. The measure of XPY. That was our central angle. Do you guys agree? And our formula for finding the measure of a central angle is what? 360 divided by the number of sides n. In this case, the number of sides is 4. Very good. So we're going to do 360 divided by 4. What's the measure of our central angle? 90 degrees. All right, let's do the next one. We've got the measure of XPQ. XPQ, guys, is this guy right here. If the central angle was 90, what does that angle have to be? 45. How did you get 45? You divided the 90 by 2. So this one's going to be 45 degrees. And what about the measure of PXQ? Where did I get 45 from? Someone answer that for me. German? Which one's an isosceles triangle? XPQ. How do you know it's isosceles? Uh-huh. Right angles make triangles isosceles. Never mind. You're on the right track, though. Remember, we already know, German, that this angle is 45 degrees. How can we figure out the last angle over here? Bryson?
That's 45, and then x, y is like congruent. So like this in half.
Oh yeah, it is split in half, but it's split in half with these two. That QY is not part of our triangle, Bryson. Yeah, Hannah? Excellent. 90 plus 45 subtracted from 180. Or you can automatically know, is this a special right triangle? Sure is. It's a 45, 45, 90. So you can automatically assume that that last one is 45 degrees. Thank you. How are we feeling? As promised, we'll stop here. I'll take questions on this slide. Wait, who asked me why it's 45? Sophia, say it again. Which one? PXQ. Sophia, were you cool? This one we knew was 90, correct? Yes. Mm-hmm. Yeah, Gio? Yes, turn this in.